Hello everyone, welcome to our channel. In this video, we are going to solve another problem which came this year, that is in 2021 Biotechnology paper of IIT JAM. Here the question is, in the circuit shown below, the power dissipated across the 3 ohm resistor is dash watt. So we will solve this problem, but before that I would like to tell you a very important thing, very important information, that is whoever among you are preparing for JAM 2022 biotechnology paper, for you there is a good news. That is from 8th March 2021, Unacademy is starting a new batch, Achievers for JAM 2022 Biotechnology. Okay, so here you can have guidance from experienced teachers. Okay, and here you can get interactive live classes. You can have ask a doubt sessions, PDF of notes, and overall guidance for JAM 2022 biotechnology paper. So whoever among you are preparing for biotechnology of IIT JAM next year, so this is a very important information for you, and you can subscribe this course so that you can have a perfect guidance, in my opinion, and you can also use my code for the subscription plus subscription to get 10% discount. It is PHYSJAM-570. I'm repeating it, PHYSJAM-570 for 10% discount. Okay, I hope you could understand this. If you have any doubt regarding this, you can tell me in the comment section. I would explain it to you again. And now let's go back to our question. So here is our question. So here you can see a circuit where 30 volt battery power supply is connected, and here are 4 resistors. Okay, a 6 ohm and 2 ohm resistors are connected in series with the parallel circuit of 6 ohm and 3 ohm. Okay, so we need to first simplify this circuit, and then we need to calculate the power dissipated across the 3 ohm resistor, that means this resistor. Okay, so let us not guard it. So first of all, here we need to first simplify the circuit. And how to simplify the circuit? First of all, we need to find the equivalent resistance of these 2 parallel resistors, that is 6 ohm and 3 ohm. Now what is the formula for that? So if Rp is the equivalent resistance of these 2 resistors, so 1 by Rp is equal 1 by 6 plus 1 by 3. Okay, that is the resistance of these 2 resistors, 6 ohm and 3 ohm. So reciprocal of the equivalent resistor is equal summation of reciprocals of the parallel resistors. Okay, so we can write Rp is equal 6 into 3 divided by 6 plus 3. Okay, and that is equal 18 by 9, that is equal 2 ohm. Okay, so the equivalent resistor of these two resistors is 2 ohm. So we can write this circuit in this way. So first of all, this 3 ohm battery, sorry, 30 volt battery, then the 6 ohm resistor, and that is connected to the parallel equivalent resistor of this parallel circuit, that is 2 ohm. Okay, we have calculated it as 2 ohm. So it is 2 ohm, and here is the two ohm resistor. Sorry, it's not 2 pi, it's 2 ohm. Yeah, 2 ohm. Okay, now for our better approach, we can simply draw this circuit in this way. Here is our 30 volt battery, plus minus, and here you can see that this 6 ohm, 2 ohm and this 2 ohm, these three resistors are simply connected in series. Why series? Because see, the end of the 6 ohm resistor is connected with one end with 2 ohm resistor, and the other end of this 2 ohm resistor is simply connected to this end of this 2 ohm resistor. Okay, and this in turn is connected to the battery. So all these are in series connection. Okay, this 30 volt battery, 6 ohm resistor, 2 ohm resistor and 2 ohm resistor, these four parts are connected in series. Okay, so let us draw this circuit in this way. So here is the 30 volt battery, and then we have this 2 ohm resistor. Sorry, it's not pi again. I made a mistake. It's not pi, it's ohm. Okay, so it's a 2 ohm resistor. Then this 2 ohm resistor is connected in series. Okay, and then this 6 ohm resistor is connected in series with this battery. Okay, so now why did we do all this? Okay, see here, these three resistors are in the ratio 2:2:6, right? Or we can say this is in the ratio 1:1:3, right? That means if we add this 1 plus 1 plus 3, we get it as 5. Okay, and our battery is 30 volt. Okay, 30 volt battery we have. Now 30 volt battery, so if we divide this 30 volt by 5, we can get the potential difference or voltage difference across each of these three resistors. Okay, now how to do it? As I said that we need to divide 30 volt by 5. Okay, so it is 6 volt, right? 30 volt by 5 volt, that is 6 volt. So we can simply write this 1:3 to 6:6 3 times 6 is 18, or for your better understanding, we can write it as 3 into 6. Okay, let me be more clear here. 1 into 6 is to 1 into 6 is to 3 into 6. Okay, that is 6 is to 6 is to 3 times 6, that is 18. Now if we add this 3, that is 6 plus 18, what we get? We get 12 plus 18, that is 30. Okay, 30 volt. That is we can write that across this 2 ohm resistor we have the 6 volt potential difference or voltage difference. Across again this 2 ohm resistor we have the 6 volt voltage difference, and across this 6 ohm resistor we have 18 volt voltage difference. Okay, so if you add it up, it is 6 plus 6 plus 18, that is 30 volt. So this 30 volt battery or 30 volt voltage is divided among the 3 resistors by 6 volt, 6 volt and 18 volt. Okay, so now this 2 ohm resistor, what was this 2 ohm resistor? This one, that is this parallel circuit of 6 ohm and 3 ohm. So across this 6 ohm and 3 ohm, the voltage difference is 6 volt. Okay, so the voltage difference between the two ends of 6 ohm and 3 ohm, the two resistors, are 6 volt. Okay, 6 volt. So the voltage difference across this 3 ohm resistor is, the voltage difference across this 3 ohm resistor is 6 volt. Okay, so we get V equals 6 volt, R equal what? 3 ohm, because we need the power dissipation across 3 ohm resistor, right? Only the 3 ohm resistor. So we have V equals 6 volt, R equals 3 ohm, and we need to find how much is P. Okay, now what is the formula for P? Do you remember it? It is just let us remember, P equal I square R equal, if we use V equal IR, then we can replace I square R by V square by R, or we can write it in terms of I and V, it is IV. Okay, this was the formula for power dissipation across any resistor. Now how it comes? It comes due to the heat generated due to the flow of current through a resistor. Okay, and I hope you remember that the heat generation, the amount of heat generated is H equal I square RT, right? And H by, let me just show you so that you can understand. So H equal I square RT, right? T is time, I is the amount of current flow, and R is the resistance. Okay, so H is the heat generated. So H by T, heat by unit time, is the power dissipation, right? Power dissipation is heat generated by unit time, that is equal I square R. Okay, and from V equal IR, that is from Ohm's law, we have V equal IR or I equal V by R. That is, if we put V by R in place of I square, we get V by R whole square into R, that is equal V square by R. Okay, so P equal I square R or V square by R, and even if we put V equal IR here, then we get P P equal, it is I into IR, right? That is, we can write it as IV. Okay, so we can write P equal I square R equal V square by R equal IV. Okay, so from this we get the formula, and let us go back to our question. So here we need to find this P. Okay, so P equal, we need to use which one among these? See, here we have this V, which is equal 6 volt, and we have this R equal 3 ohm. So we need to use P equal V square by R, because we have V and R, right? We don't have this I. So here P equal, here this P equal V square by R, that is equal 6 square by 3, 6 square by 3, that is equal, 6 square is 36 by 3, that is equal 12 watt. Okay, the unit of power is watt. So 3 times 12 is 36, and the answer is 12 watt. Okay, I hope you could understand the solution. If you have any doubt regarding this solution, you can tell me in the comment section. If you like this video, please click on the like button, share this video with your friends, and don't forget to subscribe our channel. Ta-da!